So we're going to learn our next part, which is about a molecule which is known as Kevlar. We're going to know about this molecule. So Kevlar, what are they? Kevlars are actually polyamides. They're polyamides which are actually tough. Or you can say these are tough polyamide. Polyamide. Now, water amide, we obviously know a molecule which contains this linkage, yeah, that is known as our amide group. Or the other way could be there, NHC double bond, NHC double bond. So okay, so this is our amide group linkage, and it continues. That's known as our polyamide. Okay, polyamide. Now, where is it used? It is used in bulletproof vests. So those which the military defense people you wear, or the police guards they wear to like protect themselves. In those sort of materials, this Kevlar is used. Those are bulletproof vests are being like made by the help of Kevlar. Okay. Also, it is also, that means one of the uses is bulletproof vest, and another use is it is used in high specification bicycle tire. Okay, that means bicycle tires which are like very strengthened, which are, let's say, mountain bikes or race bikes. Those sort of high tensile bikes are used. High specification bicycle, sorry, BI tire. Okay. Now, how does this is also a polymer. Okay, Kevlar is also a polymer, but this Kevlar is formed from certain monomers. What are those monomers? Monomers of Kevlar. Let's see them. So one of the monomer is this part. Remember, we are actually studying what? Condensation polymerization. Or much of our A2 contents are regarding condensation polymerization. Okay, we will deal with only condensation polymerization in our A2 contents. However, addition polymerization is mostly dealt in like O level, and you could say we don't have actually polymerization in AS, but yeah. And we have, but do like recall the concepts of or like your A levels, because those are very like easy to remember and easy to go polymerization, because you know if you have a repeating unit and that continues to repeat itself, we have just only one polymer and that's adding itself again and again. But here, one little compound in condensation polymerization, one little compound is eliminated and two different monomers is used to form a polymer. Okay. Now, this is our phenylamine, or you can say diphenylamine. Diphenylamine and what? This is diacyl chloride, you could say, but with a benzene in the middle. Okay. Now, this molecule, okay, this molecule, it does not exist like in our natural environment. We need to like produce this material. Then how do we produce this material? Okay, let's see. In order to produce this material, we at first take pure benzene. Pure benzene is taken. So preparation of this molecule, you could say, preparation of the starting material. So in benzene, we would add CH3, what? Cl with anhydrous AlCl3. See now where why these conditions and why these reactions are coming. So in order to produce this bulletproof vest, we need this Kevlar, and to produce Kevlar, we need one of the monomer, like these two monomer, and one of the monomer, it does not, both the monomers actually does not exist in the room temperature or in the natural state. We have to produce this. Now benzene stays in the natural state, in the natural environment. From benzene, we can actually make this reaction, which is Friedel-Crafts alkylation. So from this Friedel-Crafts alkylation, we can form our required alkalis, let's say CH3. Okay. And further, if we add CH3Cl, with AlClC. This should be also anhydrous. I'm not writing it. Okay, write it by yourself. This should be anhydrous. Okay, and we know either CH3 adds in the second group or the fourth group or the sixth group. We need the sixth groups one, so we will take the sixth group, and from here, once the fetal like the alkyl groups are added, what happens? What do? We make them undergo oxidation reaction. So okay, MnO4 in H plus with heat under reflux, we should form what? Both the alkyl group will be, or the side chain will be converted to what? Carboxylic acid. Now, since we have a carboxylic acid in this case, the rest of the equation is nothing difficult, which is just as PCl5. We know adding PCl5 to our carboxylic acid, we get what? Acyl chloride. So we are left with our acyl chloride. Okay, this is the formation of our acyl chloride or diacyl chloride in the benzene molecule. Now for the phenylamines part, diphenylamine, or let me draw the structure directly. So for this one, we know already what things we need to add. So let's do again. This is just a benzene. From benzene, what do we need to do? We need to form like nitration of benzene, isn't it? So concentrated HNO3, concentrated H2SO4 at 55 degrees centigrade. What does it form? It forms our nitration, like nitrobenzene. So let's say this was the molecule. Okay. Now, when we add SN in concentrated HCl with heat, at the same time, we apply a little bit of OH minus, okay? Now, why do we apply OH minus? I will define it later, but these are the two conditions we have to add together, okay? I will define about this OH minus a bit later, but let's go with the flow. Now we are going to form what? Phenylamine. Now one phenylamine has been formed here, NH2. What is the next step? The next step is to simply again add concentrated HNO3, concentrated HCl at 55 degrees centigrade. We should get now the other phenylamine. Now we don't know that second, fourth, and sixth carbon gets activated, but we just need the portion of the fourth carbon. So we add the nitro group here. Now again, making it undergo SN with concentrated HCl, then heat. And also we also need to add the second condition, which is OH minus. That means some alkali or base is added. And finally we get our required product, phenylamine. Okay, got it? So our phenylamine is produced now. Now let's come to this part, why hydroxide is added here. Now hydroxide, it is given so that the amine which is formed, this NH2, which we get, it does not react with the HCl being produced. Why? Remember, HCl is what? Acidic, and NH2 is what? Basic. And when like acid is there, that is going to react with like the amine, forming what? RnHCl plus H2, isn't it? That is going to form. So salt of the like acid, so I mean salt of the base, or you can say like this is going to form. That means some reaction is going to happen here. That means the phenylamine itself is not going to like exist, but we do need phenylamine. So in order to like prevent that reaction from happening, we add this one. Okay, that means like we know what if we add like let's say if we have NH3, what happens? This NH3 and HCl, what happens? NH4 plus is formed plus Cl minus, that means NH4Cl is formed. Okay, That means if NH2 is there, I'm sorry, like I drew NHCl, it shouldn't be NHCl, it is like it should be in this case, it should be in this manner, ACl, it should form, this is the R group, let's say, then we have NH3 for NH3 plus, and we have Cl minus. This salt will be formed, okay? So NH3Cl, so this NH3Cl, and with the R group, or which is the benzene group, this will be formed. But we don't need this group, we need a phenylamine. Okay, I hope you got it why we do that. Now moving on to the next part, how does this Kabler's reaction happen? Let's see. So the monomers are there, and we have our so-called phenylamine. Okay. Now the chlorine and one of the hydrogen, it disappears, forming what? Forming our amide linkage. Okay. So this is the portion which repeats itself. Okay. You see this portion, it repeats itself one way. Sorry, this should be a hydrogen here. Yeah. So this is the portion which repeats itself. At the same time, this is what? This is actually, this is a square bracket, and we have n such molecule, because if n of the monomers are added, n number of monomers are added in this case, what should be the byproduct in this case? 2n plus, sorry, 2n minus 1 HCl, remember? So these are the two products formed. A small substance which is HCl being eliminated. Now, moving to our next part, we have, let's say, these amide groups, or we want to form the amide group. So if we want to form amide group, what are the monomers? The usual monomers are, let's say we have CH2, CH2. We need NH2 group in all the cases, isn't it? And with that, we also need, let's say, the carboxylic acid, like the short, like easiest possible way is to have carboxylic acid. So we have dicarboxylic acid. There are two carboxylic acids here. So the structural formula of these are actually this. I mean the discrete formula. Sorry. Okay. Now this is the discrete formula, and this is the structural formula given. Now when they react, what do they form? When they react, remember, they are not going to undergo polymerization. Rather, they are going to form this. What happened here? We have this CH2 part, so that means CH2, CH2, and we have this NH part, remember? So NH, NH, this two NH. Now over here we have this carboxylic acid. So this carboxylic acid is going to do what? This is going to react with this carbon, nitrogen with reaction carbon. This also nitrogen is going to react with carbon, and oxygen will be there. And these two are connected with each other. So this is actually the form, and this is the skeletal formula, you can say. Okay, so this is actually the amide linkage being formed. Like this is just to show you how usually happens the reaction if just single molecule are present. Let's say two molecules are present there. This is the structure. That means n number of molecule will do what? Like let's say bigger ring containing all this repeating unit will be formed. Since there are just two molecules here, I just gave two molecules in this case. This is the structure being formed. Okay, but this is also a chain here. Now let's learn about polyesters. Now polyester is, we know ester is made from what? Carboxylic acid and alcohol. But polyester will be made from diphenol. Now we know carboxylic acid is acidic and alcohol is sort of neutral, but they react with each other, replacing the oxygen, forming a new ester group. Now, if this is our one of the molecule, and I mean one of the monomer, and another monomer is, let's say COCl, then we have this C double bonded with O and this COCl. That means how does this structure look like? The structure looks like the central carbon has this oxygen bond and the other portion have OCl. Okay, this is actually how it looks like. So I've just drawn the structure, like the structure here. Now, since the phenol itself is acidic, it does, like, if another acid is present here, so instead of this, let's say this acyl chloride, we could have, let's say, like, well, how does usually ester form? Carboxylic acid plus alcohol. But if we, like, let's say this is the OH group, and if we have introduced here a carboxylic acid, COOH, what will happen? Let's say this is the another monomer being formed. What will happen? This is acidic, this is acidic. No one will react, isn't it? Because both are acidic. That's why, but we need this, like this group, which is our C11O, like we need this group. But how can we do the reaction then? Because ester needs this group. Now the alcohol, the phenol has this group already. But if we can't provide any acid, then how should we bring this one? The possible answer is having an acyl chloride. So acyl chloride is introduced. Since acyl chloride will react with this hydrogen, forming like this HCl, this oxygen will react with this carbon, I mean this oxygen will react with this carbon or form bond with this carbon, forming our polyester or the ester linkage, okay, forming this molecule. This is the molecule we are actually looking for. So wait, let me see. Yeah, so this is the repeating unit, you could say. Okay, so that is basically it. Because let's see, if this is the case, we can have the other portion here as well. Just drawing it like upside down. Okay, so I just like flipped it, like making this over here and making like bringing this to the down. So I'm just flipping the position so that like it goes with the flow. So, and it continues up until we get another, let's say, oxygen of the phenol, and there's this phenol group present there. Okay, so there's this phenol group present there. So that means this is the repeating unit. Now, a second such situation could be, let's say, we can, like, instead of just two carbon, like this much of bond length over here of the carbon, we can have, let's say, a larger monomer. The phenol, diphenol remains, let's say, the same. Okay, but we have, for the sake that, let's say we have a larger molecule, larger monomer of COCl, then what will be the product? The product in this case will be this one. Wait. So this is going to be the product, let's say. Let me draw it towards the right. Oh. We have this C here, oxygen, O. So this is the phenol we are actually talking about. So here could be other oxygen. Again, like this can continue. Okay, and it continues. And over here also, let's say oxygen, carbon, discontinuous. Okay, and there we have the carbon part. And it continues. Okay, so this is such of a molecule, I mean the product. Okay, now moving to the next part, we come to a region where we can study about homopolymer and heteropolymer. Homopolymer and heteropolymer. Now, what are homopolymer and what are heteropolymer? Homopolymers are those where the monomers are identical. Okay, like single monomer is used. Heteropolymers are what? Heteropolymers are those where like it contains, let's say, I mean, different monomer could be present there, you can say. Okay, so let's see. Let's see an example. Let's say our monomer is this amino acid. And wait, let's say we have a couple of examples of amino acids. We have, let's say, CH2, CH2. I mean, normal acid, not gas amino acid. We have, let's say, this, like, all the portions same. Okay, this is, let's say, one of the like monomer. And then we have, let's say, HO2C, CHR, NH2. And we have, let's say, HO2, CH, OH, CH, COOH. Okay. Now, about homopolymer. Homopolymers, why do they have like single monomer, and heteropolymer, why do they have like different polymer? Let's see. Before that, let's construct this portion. Let's say we have two such monomers. Okay, two such molecule. Let's say this is a monomer, in this case HO2, CCHR, and H2. Okay, and H2. This is what, CH. I have given double R here. Sorry, HO2C, CH, R, and H2. Yes. Okay, this is our monomer. Now, if that's the case, let's draw the structure. This is our C double bond C, H, R, and we have, let's say, N, H. Okay. Now, if this is a molecule, sorry, NH, and we have, let's say, another same looking molecule, what happens? This acid, it reacts with this amine, isn't it? They will react and form what? They will form amide linkage. The linkage should be something like this. And there it goes on, there it goes on. Like if we have, let's say, another monomer here to the right, that means what? This is going to again repeat itself, isn't it? We will have this beautiful looking like monomer. Let's say again we have this same molecule. That then what will happen? We will have this NH group, and we have this CHR, C double bond O. Like it repeats itself, isn't it? Now see this one. this one, like, sorry, this molecule, they have the same pattern, isn't it? They have the same pattern, yeah? Every of them are identical. Like, you see that it is repeating itself beautifully. It's repeating itself. Okay, this is known as the homopolymer, which repeats itself in a beautiful sequential manner. Like, nothing changes. This pattern also, NHCO, 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 it completes the bond like NHCO. Not like, never it will happen CONH. Like, it won't change. It will go with one single flow. If it was initially CONH, let's say, it will go on with CONH, CONH, CONH. But if it starts with NHCO, then it will go on with NHCO, NHCO, NHCO. Like, whichever comes first will always come first. Okay. Now, let's talk about heteropolymer. Now, how does heteropolymer looks like? Let's say, yeah, let's say we have, from the above example, from the above monomers, let's say we take 2 of these monomers, okay? 2 of this monomer. Then what will happen? Then we will have, let's say, CH2, CH2. There will be this oxygen group, there will be this oxygen group. And on the other side, we'll be having, let's say, the carboxylic acid part, okay? And sort of, let's say, if there's another alcohol group here present, that will form CH2, CH2, oxygen. Like, this will go on, isn't it? Now see what happens. This is the extra linkage, but the extra linkage flipped. Initially it was OCO, but now it's what? Like COO. Like, the position changed, isn't it? Like, it flipped. That means it is now in a different pattern. Let's say instead of this, let's say we have carboxylic acid and amine, diamine. Okay, CH2, CH2, NH2, and here NH2. And we have, let's say, CH2, CH2, COOH, and COOH. Okay, now let's see what happens. CH2, we have NH, we have this CO, and CH2, we have the CO, this NH, and it goes on. Let's see what happens. Initially it was NHCO, but then it changed to what? CONH. See, it changed. This is known as heteropolymer or copolymer, you could say. Sorry, wait, copolymerism. Okay, so basically copolymerism means this is not actually heteropolymerism. This is like one such thing that we need to concern about, like the amide linkage which repeats itself. About heteropolymerism is something you will be getting, let's say, the copolymers. Copolymers means that, let's say, if this is your main chain, then this might not contain any longer. Like, this might not continue any longer. Why? Because if it has a branch here, that branch might continue itself. Now, if it had another branch, it might continue again. Like, this way it goes on. Okay, that's known as heteropolymer. That means the polymer is not sequential, or is not, let's say, like having a solid, straight, smooth structure, like not a single chain. So monomers such as, let's say, that's why this example is given actually. Like, this 2 monomers are just given. Like, instead of them, let's say all 3 are being reacted. What happens? Here we have alcohol in the middle. What will happen now? This will do what? Let's say we have one such molecule, which is let's say one such molecule where we have, let's say, CH2, okay, OH, or like O goes there, it's hands free, and we have this O here, let's say. Okay, now the carboxylic acid was so far so good. Let's say this is H, this was OH, okay, and this was, let's say, CH2. We have this CO, like this goes on. But let's say instead of reaction like, if let's say we have amide linkage here, let's say, like I feel like amide, like amino acid is presented here. That means what? COOH and COH and what? We have CHR. Then we have, let's say, NH2. That means NH. Okay. Now this one will react with this one as well, isn't it? I mean, sorry, if this is the other case, like the other way around. Let's say there we have N over on the right left side, NH. Okay. Now this looks fine. So then this phenylamine can actually form bond with this carbon, isn't it? And that portion, let's say this is actually carboxylic acid part. This goes on, or like this goes on. But here we have an alcohol here. Any of the acid can actually come here and also start forming bond here. If that's the case, then what will happen? Their new like linkage will be now created, and from this nitrogen, let's say another carboxylic acid came, and COO, let's say CH, we have OH, and we have, let's say, H2 and C double bond O, it goes on. And let's say now below here, we have another OH, which in turn will further react with, let's say, some other carboxylic acid. Okay. And what happens? And it goes on and on and on. CH, HN, C, H, OH. Like it goes on. Okay. That means what? The chain is not having a constant, like not a single main chain is maintaining. Rather, the chain is now being subdivided. No more having a consistent single chain. The chain is now changing itself. The position of the chains are changing. Okay, so this is known as our, like you could say, the heteropolymers part, that it changes. Got it? So in our next class, we will be studying more about like the Kevlar structures. Then we'll be studying HDPE and LDPE, which is high density polyethylene and low density polyethylene. There we will see about like the heteropolymerism and like homopolymerism's effect. Okay, so yeah, that's all for today. See you in the next class.